Hello everybody and welcome to Leaders of Learning, a thought leadership series by CodeChef. In this series, we speak with Vice Chancellors and academic leaders who are shaping the future of higher education and computer science education in India. The goal of this conversation is simple: to learn from their experiences, understand their vision, and share those insights with students and educators across the country. Today, I am really delighted to be joined by Professor Priyadarsan Patra, the Vice Chancellor of NIST University, Odisha. Professor Patra brings with him a rare and powerful combination of deep academic leadership as well as extensive industry experience. With over 3 decades of leadership experience across academia and industry, Professor Patra has served in diverse roles like Vice Chancellor, Professor, Chief Architect, Principal Scientist, Provost, Director, and Dean. Beyond his academic leadership, he has also spent over 20 years driving world-class research and development. His work spans across system design, validations, low-power architecture, AI-driven innovations, and large-scale R&D leadership. And above all, Professor Patra describes himself as a dreamer, a scientist, an educator, and a community builder who is deeply committed to nurturing curiosity, lifelong learning, and creative problem solving among students. So Professor Patra, it's truly an honor to have you with us, sir. Thank you for taking the time to join this conversation.
Thank you for this opportunity, Mr. Joshi. I'm excited to discuss how we can shape CS education or higher education in general for India's future.
Thank you, sir. So before we begin, I also want to give a quick note about myself and CodeChef. I am Jason Joshi. I lead curriculum at CodeChef and also the content generation at CodeChef. I come from an academic background, also have been served as assistant professors, and I continue to stay closely engaged with teaching and curriculum development. And CodeChef is a global learning and assessment platform which is focused on computer science education and programming education, working closely with students, educators, and institutions across India and internationally. Now, this series that we have is a part of our new talk series that we have launched called Leaders of Learning. And this is not a commercial initiative. It is purely a space for reflection, ideas, and dialogue on education. All right, so with that context, dear sir, I would like to begin by learning a little bit about your own journey. You have had an extensive journey across academia and also the industry. So could you briefly share what shaped your academic path and how those experiences influence your role as a university leader today?
Sure. My journey has really been about building a bridge between two worlds. The rigor of global industry at places like Intel, where I tackled cutting edge chip designs and scalability of intelligent systems, and the academic institutions where we have the power to transform a nation and its people. Briefly, I did my school and college, early college in Odisha, and then I got my bachelor's degree in engineering from Indian Institute of Science. Since then, I moved to Massachusetts to get my master's degree, and eventually got my PhD degree from the University of Texas at Austin. And after a short stint at teaching, I joined the Intel Research Labs. I spent about 22 years over there, and then I returned back to academia. And for last 7-8 years, I have been serving India in various roles in the academia here. as you mentioned some of them. Moving from a researcher and a technologist to a founding vice chancellor for a university like NIST University has taught me that leadership isn't about presiding over an institution. It is about really architecting the ecosystems that would thrive for years to come, and to create a culture that supports such a thing. And what shaped my perspective most, perhaps, was to see how technology can democratize opportunity. At Intel, I witnessed silicon powering the global innovation. In India, I saw great potential, but certain gaps in access as well as accessibility remained. I view university leadership through this global local lens, what I call it. Bridging the Silicon Valley standards, if you will, given my US experience, to solve our own regional challenges in India, be it in rural skilling of AI, for health perhaps, sustainable agriculture, 5G and next generation communications, smart mining, marine biotech opportunities. These are some of the things that we are working at my current university. Besides that, our students must compete globally while staying rooted in this land, in their own country. There is a third dimension to my outlook through my long-standing engagement with grassroots and sustainable development initiatives, including my work with organizations like SEEDS. SEEDS is a Sustainable Economic and Educational Development Organization, which I founded when I was a student myself. I have seen firsthand how technology and education must ultimately serve the people. Working closely with students in these contexts actually reinforced for me that leadership is all about building character. And I thought it is a great opportunity. That is what higher education is really all about. Therefore, these perspectives and experiences of mine continue to inform my own journey, as we just mentioned.
Right. Thank you, sir. Thank you so much for sharing about your background. See that you have an extensive educational background, and also the fact that you have had a great experience working with high-level industries, and then you have come back to academia, which really gives you a proper perspective on how to shape the students for the future. And the fact that you shared that our students should compete globally while being rooted in this country, that's a great insight, I think, that we should all think about. Yeah, thank you so much, sir. Now, I also want to talk a little bit about the vision that you have for higher education. So from your perspective, like, how do you define the role of higher education in today's rapidly changing technological and societal landscape?
Right. So higher education is no longer a static, stale repository of knowledge. It is a foundation lab for young minds of a country. So in a world where information is a commodity now, and as you mentioned, it is rapidly changing, also so-called the languages, syntax, and the frameworks that people really study, they have a half-life of just few months. Every so often, every couple of months, new models, systems, technologies, and applications are showing up. So therefore, agility and flexibility of the mind and of the action is what is called for. In addition, there must be ethics and wisdom infused into higher education. So it's not just technology, creativity, but also agility, flexibility, and ethics that makes it, which play an extremely important role. So since the 1990s, if you see the tertiary education, meaning college and university education, has moved from being a scarce privilege to a mass aspiration, especially in a low to middle income country like India. Global enrollments, if you look at, is rising from the 52 million in the 1990, and it is expected to grow to about 500 million in year 2040. And so that's in a span of 50 years. You see that the number of people who are getting educated in higher education is growing by 10x, an order of magnitude. That is extremely significant. So the questions that arise are, how do we manage expansion of education without sacrificing quality, relevance, governance, and equity? And how to finance such expansion without imposing unsustainable burdens on the public coffers or family households. So the mission I believe in is to produce not just graduates, but adaptive, enlightened citizens with ethical grounding to steer technology towards social good, not just efficiency of technology.
Right, sir, right. Thank you so much for sharing that vision and for stressing the importance of ethics, which is something in today's world which we often miss out while we are covered in the great sea of technology. So like you rightly mentioned, sir, when we talk about syntaxes and things like that which are changing very frequently, I also want to talk a little bit about the future of computer science education. Right? When you look specifically at computer science education, like what do you see as the most important changes or shifts that institutions need to make in the coming years? Because we know that things are changing very rapidly.
Yes. From my perspective, as a Vice Chancellor, a computing professor, and someone deeply engaged with AI and R&D and institution building, the most important changes in computer science education over the next few years are not incremental syllabus tweaking. We need both structural as well as philosophical shifts. I would frame the changes under few priorities. One, for example, I would say we must move from being programming centric to system thinking and intelligence centric. For decades, CS education has oversubscribed to syntax, languages, and frameworks. These remain necessary, but no longer sufficient. The shift must be towards systems thinking. By that I mean hardware, OS, cloud, data, edge, and AI interplay. The whole shebang is what is system. Thinking about model-driven and agentic reasoning. Okay? And understanding how intelligence is embedded into systems, not just coded. So graduates must know why systems behave as they do, not just to write code that runs on a computer. So that's number one. Number two, actually, as I have said, these frameworks and APIs and libraries, they have a very short half-life. So CS curricula must therefore emphasize conceptual durability. What do I mean by that? I mean, focus on algorithms, architectures, optimization, distributed systems. Similarly, data abstractions, probabilistic reasoning, learning theory, security. AI is a computational paradigm, not just a tool. This is what would be a grave mistake if we simply teach it as a tool, especially for computer science education. So students should graduate with knowledge that survives multiple decades to come. Because, as I said, the hype about the half-life of the current tools. Now, as I said, the students should aspire not just to do individually coding, but they must learn how to orchestrate, how to architect intelligent systems. That will mean they need to understand how to define goals, constraints, and guardrails, how to design workflows where, let's say, the AI agents can then plan, reason, and act. They must be able to evaluate the outputs of these intelligent systems for not just correctness, but for bias and alignment as well. And the curriculum must also transform itself from static curriculum to a living lab. So teaching environment must transform into living labs, is what I would say. And ethics, I have already emphasized that ethics cannot remain a chapter in a book that we must read and finish so that we have complied with the requirements. But ethics must become a constraint that an engineer, a scientist can specify and ensure that the ethics is satisfied in the systems and units that we build. And finally, of course, there are many points, but if I say job readiness could be the other thing, CS education must emphasize or put a significance over, because there is a biggest risk in CS graduates is not getting not just being unemployed, but being rapidly obsolescent, meaning things are changing so fast, and the low-level coding is replaced by intelligent systems. That means rapidly things are becoming obsolescent. So these are some of the points that I would like to point out.
Right, sir. Thank you so much, sir, for that. So, like you rightly said, when we think of computer science, people always, the first thing that comes to the mind is learning some programming language, syntaxes and stuff like that. But here, like what you have rightly suggested, it is about system thinking and that kind of mindset that should be there. So that is what will lead in the future of computer science education. Right. Thank you so much for that, sir. Now, just adding to that, like we talked about the things that are rapidly changing, the emerging technologies, but also I just want to talk about the fundamentals, sir. So this is one of the challenges that universities or institutions face, right? It is balancing the fundamentals with the fast evolving technologies like AI, data-driven systems, and so on. So fundamentals are also important, and also it is important to stay at pace with the emerging technologies. So how do you think that universities can strike this balance effectively, sir?
So certainly, it's a very hard balance, but very important one. Our education in the universities must still focus on the core computer science fundamentals, because those are the foundation stones. We cannot build the fifth layer of a building without the foundation being strong or existent. So data structures, algorithms, operating systems, computer organization or architecture, computer networks, databases, and object-oriented programming. These still remain fundamental in my view, but they must all be informed today with AI. So whenever we teach any of these things, we must connect. Why does this matter in the real world? Any of these topics. And then where is the modern intelligence infusion comes in, and how can we be ready to understand and infuse intelligence as we go forward, as the student grows, out of the university and goes out the real world industry or academia, wherever the person goes. So it's very important for us to do the fundamentals, but understand the big picture. That is what we are saying. The other thing is the paradigm has changed. Now we should think about practice first, theory second approach. So, the traditional rote learning or theory only kind of learning, it is overwhelmingly, for an overwhelming portion of the learners or students, it needs to be now practice first, theory second. But there will be still some brilliant students. I was lucky to have some of professors, great professors. When I was studying, 4 of them were Turing Award winners, like Nobel Prize winners in computer science, for example. So there I could see the spark in some of my classmates and other students who focused on pure theoretical computer science. It's formalism, mathematics, computer science, etc. That there is still need of those fundamental research, but that is significantly smaller and applicable to the vast majority of the learners and students today, especially in an average university that you will see in India. So therefore, what I say, if you hear it, you forget it. I'm borrowing somebody's quote. If you do it, you remember. So that is what the mantra is. And regular industry-linked mini projects have become very important. Okay. So in the class, it relates to practice first, theory second. But how do you practice? By having industry-linked mini projects, learning how to do API building, full stack mini applications, networked applications, group projects, teamwork, testing, verification, validation, reviewing, documentation. All these need to be taught to our students, which typically was not done when I was growing up as a kid. Yes. And then I already mentioned about systems thinking, problem solving, critical thinking. These are key things in no matter what we teach. It always has been important. We may be emphasizing nowadays a little bit more, but problem solving and critical thinking has always been the main resonator of any higher education institution, and that must continue. Basically, a great engineer also needs great communication and must learn teamwork. These are very important. Open source experience, that is also quite important and interesting. Students must understand open source, not just to use tools that are open source and cheap and so they can use. That is fine, but they must also have that experience and even contribute to the development of open source if they can, while they are students themselves. Some of these things that would be needed. So industry exposure and real world problem solving. Here the faculty and the institution and the industry ecosystem of the nation, the country, the government, that they each have their own roles and responsibilities to attain what we really need to transform our country into a global, big heavyweight in innovation and higher education and knowledge creation.
Okay, yes. Thank you so much for that insight, sir. Like you said, it's quite a difficult balance to strike, but yeah, practice first, theory second approach would be the right way to go ahead with this. So, sir, since you come from an industry background and is now in academics, so you are the right person to whom I can ask this question. Given your deep experience in both industry and academia, like what role should industry exposure and real world problems play in technical education today? You already mentioned a little bit about it in the previous question, but if you can elaborate.
Can you re-ask? I couldn't hear entirely your last sentence.
No, I was saying that given your deep experience with both industry and academia, what role should industry exposure and real world problem solving play in technical education today?
Right. So they have a crucial role. As a matter of fact, I am encouraging, my faculty to actually take even some industry sabbaticals, because it's that much important. The classroom to boardroom, meaning industry, wall must become porous. That means the exchanges must happen both ways. Industry exposure isn't summer internship checkbox. I did my summer intern, I'm done. Industry exposure ho gaya. So that doesn't really work. So it is let's say if you are a medical student, you must actually work in hospitals. You must actually perform in some clinics before your graduation from the school. Similarly goes for the engineering students, where they must have integrated real world problems they must solve. So even from a second year, I would propose that the students work with messy data, legacy code, shifting requirements, because this is what they will face when they actually go into employment. So this is something that must be taught early on. And how can that be taught without the collaboration of the industry? Because they would know that most. And so I'm introducing in various institutions, I have led this concept of POP, or Professor of Practice. So we are bringing in people, who have real world experiences. They may not have all the requisite degrees, so to speak, academically, but still they have a wealth of. So that is one way. We are engaging our alumni, for example, who are in various, senior positions in the industry, engaging them and getting our faculty to mandatorily visit some industry locally or nationally, if possible, financially sustainable, go for the industries that exist so that they truly understand the problems faced by our communities, our industries, and our governance bodies. Like the government, for example, has needs too, which we must understand. And also, we incentivize experimentation with such what we call as experiential learning. It is still a work in progress, I would call. It's not, it's very challenging, and from perspective of financial ability of smaller institutions, but we're trying to encourage industry to really collaborate and partner. After all, our students are the ones that will go and populate and boost their engines of success in the industry. This is my view. I express every platform I get.
Yes.
Yes.
Yes, sir. The fact that you said that the wall between the classroom and industry must be porous, that's a, I think, great point that we can think about. And the example that you gave for medical students, for them to become doctors, they have to go through that hospital experience. So I think that's the same for technical education as well. Yeah, very insightful points that you have brought out, sir. So I just have a couple more questions, sir. I know we are a little ahead of time. I'll just finish it quickly. So you also were talking about the faculties, right? The faculties are actually they are central to our educational transformation. So how can institutes actually support and empower faculty to adopt new pedagogies, tools, and approaches to teaching?
Right. One thing I'm enabling for my faculty here is what I call it self-updation, or sometimes traditionally people have done the faculty development programs. They attend certain 5-day or week event, but we are augmenting that with supporting faculty to get learning licenses, such as, let's say, some Coursera or openware from MIT, Stanford, or even NPTEL and SOEM platform courses, etc., to learn and get certified, supporting that effort. We are also trying to incentivize experimentation. Perhaps some faculty wants to introduce VR, virtual reality simulations, or maybe even experiment AI tutors. We have not gone that far, but at least I'm thinking and mentioning that they could even think about combining, hybridizing their teaching with AI tutors. So part AI tutor and part physical, real, warm blood human beings, teachers teaching. And basically, how can we kickstart our frugal innovation genes? We are known for frugal innovation as a country, and can we apply that to education as well, is what I try to urge my faculty. Industry immersions, I mentioned about faculty sabbaticals, going, industry visits, having that more frequent, and a little bit more immersive experience. Peer teaching circles with maybe AI hybrid, how they can actually multiple teachers, maybe some industry expert and the academic expert or teacher, they can collaborate to teach a course. Few real world cases, case studies could be brought through the mechanism of interfacing with the industry there. These are some of the things that we are trying, and I see progress, but it is still long road ahead. to go.
Okay, yes, thank you, sir. So, this is my final question now, and so I just want to have your insights on how to prepare our students for the future. When I say how to prepare them for the future, it's beyond the technical education, right? What skills or mindset do you believe that students must develop to remain future ready and adaptable over long careers? You already mentioned about ethics, which is a great point. So, what other things do you think are important here? And along with this, you can also give any closing advice to the students and educator communities who are shaping the next generation of technologies today.
Sure. Beyond the traditional languages, Python, Java, etc., the students, I believe, as a matter of fact, I believe very strongly that they must learn to learn. So what is fundamental is learning to learn, the ability to be a learner lifelong. As a matter of fact, I myself consider as a student, lifelong student. Some of the characteristics I will say, I mentioned about flexibility. There I mean cognitive flexibility. How can you toggle between different deep technologies, for example, and human collaboration to achieve, certain larger systemic goals that you would have. Teamwork. Can we move from I to we? Can every one of our students learn to speak in the language of we as opposed to I? That is where teamwork. Resilience. Learn to debug a career. The student must be ready to understand and be able to debug their own career, not just their code, but their career as well. So because their future growth paths are not going to be linear. It's not like you just become, an assistant, then an associate, and then a full. If you are academics, you can think about that, or junior engineer, assistant engineer, whatever, on the engineering line. It's no more linear like that, and one area, it will not happen. So they must have that resilience, meaning mental resilience, to be able to switch and learn adjacencies, right? It would be adjacent areas that they must be able to learn. And social conscience. I mentioned ethics is one. So social conscience is like asking the question, should we, instead of just asking, can we? Many things we can, but we must have the ability to ask the question, and the courage and the conviction to ask the question, should we? So, and so you asked me if I can say a few closing remarks. So there I would say that the next phase of computer science education is about creating thinkers, architects, and leaders of intelligent systems, not just coders. So to our educators, I would say, don't fear AI. Don't fear AI. Your mentorship and human spark will endure for sure. So please leverage AI. Please understand AI. Please learn AI. Please use AI. Please create AI, is what I say to my educators. To my students, I say, be the future authors, be the producers, not just users and consumers, but be the producers, aspire to be the producers. So, but stand on ethical ground, discover your passion, try to discover. Passion is not a well-defined thing that is available to you and suddenly and you will be working. Please feel free to dream and discover your passion. If Indian universities get this right, such as mine, they will not only supply talent to the world, but shape the global direction of computing itself. This is my belief.
Thank you, sir. Thank you so much for that wonderful insights that you have shared. So, the importance of ethics, the importance of resilience, the importance of leadership, team building, all these things that you shared are wonderful insights for our student community, sir. And also for our educators, as you rightly said, we don't need to fear AI. The human spark will always endure, and we can use AI as a tool that can help us in our education system. So thank you so much, Professor Patra, for sharing such thoughtful and insightful perspectives. Your experiences across research, industry, and academic leadership have offered us a valuable guidance for the students and educators and institutions alike. So it has been really a great privilege speaking with you today, sir. And as I said, this is our first episode of Leaders of Learning series, and it's a great honor for us that we had an immense personality like you who have joined us for the first episode. So thank you, sir. Thank you very much.
Thank you very much. The pleasure is mine.
Yes, thank you so much, sir. And to our viewers who are out there, thank you for joining us for this episode of Leaders of Learning. If you find this conversation valuable, do share it with your fellow educators and students. And we will be back with more conversations featuring leaders who are shaping the future of education. Thank you, one and all. Goodbye.